Hello everyone, welcome to the another very important session in which we will be discussing some more important questions and the concepts for our upcoming CSIR net and the GATE physics exam. So I hope that the discussion we are going to do today in this session will be getting clear to all of you. But in case if you're going to have any doubt anywhere in the discussion we will be doing today in this session, you can surely let me know about it and we will try to consider those points then. And guys, I'm gonna consider some of the important questions today in the session from the give me a second, nuclear and elementary particle physics part. Okay, so first of all, before going ahead with the discussion, guys, I would like to show you the important slide regarding the latest offer, which is gonna be there just till 12th August. So in that case, if you want to grab it, it's just gonna be for some time now, and you have to use and apply the code Anjali Live to get the discount in the total subscription amount. Very good evening, Sakshi. Very good evening, everyone. Okay, so in that case, guys, even if any of your friends want to start their preparation under the guidance of top educators, you can share this information with them, let them know about it. And by using and by applying the code Anjali A Live, they will be able to get the discount in the total subscription amount too. When the offer is going on, you will be able to save more. Now, let me just show you what are the benefits you will get if you are going to take the Unacademy Plus, Iconic, or the Light subscription. So actually guys, you can see it on the screen. These are the benefits you will be getting if you will be taking the Unacademy Plus subscription or Iconic or the Light subscription. And other than that guys, even now the notes are important notes are available on the learning app, which will be helping you to take your preparation to the next level along with the well structured and well planned courses by the top educators. So this is how everything will be helping you a lot to do the best preparation under the guidance of top educators. Depending on whichever subscription you think will be helping you more and you find more beneficial for yourself, you can take that subscription and start your preparation today under the guidance of top educators. Very good evening, Deepika. Very good evening, everyone. So I hope guys you all are ready for the discussion today, and I will be starting to give you the questions now. Here are a few more slides. This one about the Unacademy Learning app. This is something about the session. Here, few details about me. Here, something related to the community feature we are having on Unacademy Learning app, which will help you to know about the latest updates and all the important things you need to know about. Now, let's just start the discussion about our first question, guys. And like you know, as much practice as you keep on doing, it makes you feel more confident. It lets you know about the more concepts and the things you need to prepare, which are important for your exam. So, this kind of practice is very much important, right? Let me just write the first question right now. It's here. Which of the following decay process, and also guys, today after this session we will be having our spatial classes as well. For the spatial classes you can check out on Unacademy Learning app. Those are the free live sessions, so you will find details there in the spatial classes or free live classes section. Either you can check it on my profile in the upcoming free live classes or the spatial classes. Okay, so it will be visible to you. One of them is on the spectroscopic terms, where I'm going to introduce the spectroscopic terms, how to find the ground state spectroscopic term, how to use the trick to find it, okay, all that. And the bright scheme, that's what we will talk about. We'll take previous year questions. The second one is about the electromagnetic theory. So this is how the two sessions we will have there. Decay process is allowed. Processes, so it should be. This is neutron. Try it now and let me know as you will get it done. And whatever is the right option according to you guys. And if you are gonna get it wrong or you are not gonna get it, then I'm gonna start the discussion and I'll let you know how you have to take the steps and what you need to do in this case. What is the right answer, guys, according to you? Waiting for your reply. Okay, guys, even I'm gonna start the discussion. So actually, for knowing about the type of process, okay, we are gonna have there, we need to check out the conservation laws, right? So there is QBL, which is the main conservation. Like for any reaction to be allowed, these conservations should at least be like these should satisfy, or you can say that charge, baryon number, and the lepton number must be conserved, right? Once you're going to consider that part, very good, Sakshi, we are going to go talk about it too, that whether it is right or not. So actually, if I'm going to talk about the charge, baryon number, and the lepton number conservation, so if you will consider the first one is the charge conserved, we can see and we can say that, oh yeah, it's conserved. For the second one, yes, it's conserved. For the third one, yes, it's conserved. For the D, charge is conserved. Right, that's great. If you will talk about the baryon number and the lepton number now. So if we will talk about the K naught, it's not a baryon or neither a lepton. So it's both of them will be zero for it. But these ones, this is lepton, one is particle, and the one is the antiparticle. So their lepton number and baryon number will get conserved because total left hand side and right hand side is zero. Okay, is it zero or not? Tell me. What do you think? Means Q, B, and L are conserved in the reaction A. If I will talk about your other reaction, which is the B, if you will talk about the L mu, lepton number associated with mu, that will not be conserved in this case. And even L electron, that will not be conserved. That means it cannot be allowed, right? In the next this case, if you will see your this one is a baryon, right? But these two are not, so it will have its baryon number, but these two are not having it, so it's even not conserved. In this case, if you will see, this one is a baryon, this one is a baryon, this one like having the lepton number conserved, baryon number conserved, charge conserved, but the problem is if you will see, or you will have a little bit idea about the masses, okay, of neutron and proton and the pion, so you will see that this decay is not possible. Okay, that means you can't have this neutron giving you as a proton and the pion. Okay, so just check out their masses once and tell me, still, do you think it's possible? Is it allowed or not? This kind of decay, is that possible or not according to you? Check it out. Can your neutron particle can get decay into the proton and the pion? But remember, the masses on the left hand side should not be smaller than the masses on the right hand side. Tell me, guys, what do you think? Is this decay possible? So it's going to be 1.67 times 10 to the power negative 27, 1.67 times 10 to the power negative 27. And then when you are going to consider for pion, okay, you have to add it there in on the right hand side part. So what you will be able to get then? So your pion mass, if you will consider, that's going to be more, right? And in that situation, what will happen? This will give you total mass to be more, but a particle cannot decay into the heavier particles, or cannot give you the more mass. So that's the reason option C is not correct, but option A is. And normally for such type of questions, guys, you should know about the mass of neutron, proton, and the standard, like some fundamental particles. That information will be helping you a lot. Can I go ahead with more discussion? Okay, is that clear to everyone? If still you are gonna have any doubt, guys, let me know. We'll talk about it. But if it is clear, then that's great. We'll go over the next one. Are you all ready for the next question? Tell me if something is still not clear, we can talk about it. But if everything is clear, we are gonna take that next question now. Okay, it's here. So your correct answer for that question was option A. If something is not getting clear to you, you can tell me. I'll just read it for you. The ratio Z by A for the most stable isobar of A is equal to 64 nucleus is nearest to. Options are 0.30, 0.35, 0.45, and the next one says 0.50. Try it now, guys, and let me know as you will get it done. But in case if there is a still Sakshi, in the reaction A, just check it out. Is that QBL, all three are conserved or not? Just check and let me know. If you have confusion about the conservation of either charge, baryon number or lepton number, we can talk about it. The second one cannot be conserved because the separate lepton number corresponding to mu and electron, that's not gonna be conserved there. So second one is not allowed, right? Fourth one is not allowed because the baryon number is not conserved, right? The third one is not allowed because of the masses on the left and the right hand side. It's less on left hand side and more on right hand side. That's not possible in the decay. The first one is allowed because Q, B, and L are conserved in it. But what's your point of saying that A must not be allowed? We can talk about it. Just let me know why you are getting confused in that part and what is your point of view regarding that. Tell me, what do you think about A? The charge, baryon number, and the lepton number, did you find them conserved for A? If yes, that's great. If no, let me know. I'll show you step by step how they are conserved. I'm gonna wait for your reply. Tell me, tell me. According to you, why A should not be the right answer? We can talk about that point. Okay, that's great. Let's go for the next one then. Okay, so guys, I've noted it down. Try it and let me know what do you think is the right answer. Otherwise, I'm gonna share a trick as well as the way how you will be solving it. So I'm gonna wait for your reply and then we'll go ahead for discussing it too. Okay, and if you're gonna get it done, you can tell me what is the right answer according to you. Whatever is the right answer according to you guys, you can mention it. Otherwise, I'll let you know what should be the correct answer here. Very good, Deepika. That's great. It's correct too. Very good, Sakshi. That's great. And for them, those who don't know what to do and how to solve it, so let me just tell you there is a trick which says you can simply consider 0.015 a to the power, I think 2 by 3 as a power we are gonna have there, or is it 3 by 2? Let me just confirm it to you. It's, yeah, 2 by 3, correct. So actually, guys, in this case, when you are going to consider, is this the same, guys, you are using as well? 0.0015 a to the power 2 by 3, correct. Okay, so this is one of the formula you are having for the most stable isobar, right? Whenever the binding energy is given to you, you have the mass number A, and like all the other things are same way given to you in the expression of binding energy, then you can use it directly. But if there is any change, in that case also we are going to have the condition, that is delta B over delta Z. Find the binding energy partial differentiation with respect to Z, equate it with 0 and get the value of Z from there. So that will give you the most stable isobar related Z value, and that's your answer too. Let me know if in case there is any doubt. If you will plug in the value of AS64 in the above expression, it's quickly going to give you the answer. If you will go for the second approach, which is finding the partial differentiation of B with respect to Z and finding the value of Z after that, so that may take a little bit time, but will give you the same answer too. Okay. And in the second approach, that is the differentiation one, if you make any mistake anywhere, then there are chances of getting the wrong answer. So you have to be extra careful about the calculation for the second approach, right? Let me know still if there is somebody having any doubt, we can talk about it. But if it's clear, I'm gonna take the next question now. Next one is here, guys. Mu neutrino is even there. So three particles. Some of the questions help us to know about some facts. Like this happens this way, or this is the value for this particular case and the condition. So from the questions, even you can learn about it if you doesn't know about that earlier or you were not familiar about it. Okay. So with the questions, you can even try to learn if you find something new or different. Try it now, guys. And let me know what do you think is the right answer. Waiting for your reply, and then just in some time I'll be discussing it too. So in the question statement, they have talked about everything. Like they have mentioned the mean lifetime of the following decays for rho naught, giving you pi positive and pi negative, basically pions. Then pi naught giving you gamma, and then mu negative giving you all the three particles as shown. So this satisfied. Now here the time, mean lifetime, that's tau rho, tau pi, tau mu. That's something given to you. They satisfy the A, B, C, and D conditions. Which of them is correct? That's what you have to consider here. Okay, tell me if you're gonna have the final answer, but if no, I will let you know. Mm-hmm, mm-hmm, mm-hmm. Okay, guys, even let me just tell you about it. So firstly, what we can do, we can check out the type of interaction involved in a particular reaction. For example, the second one is electromagnetic, and because of the presence of gamma, also you can easily get to know that oh, it's electromagnetic. Due to the presence of pions, which are just your what mesons, okay. So due to their presence, you can easily get to know it will be possible with what strong interaction. Reason, because the leptons do not participate in the strong interaction, so there are leptons, this is with the strong, okay, cannot be with the strong because of the presence of leptons, as leptons does not participate in the strong interaction. So this is your weak interaction due to the presence of neutrinos as well, that's the hint. And here it will be with the strong interaction, the pair of zones, okay. So you will be even checking it with the conservation laws. Here I have told you what are the ways of finding them. These methods can work 99%, okay, correct way. But if you want to get 100% sure, you have to check out all the conservation laws, and then you will finalize the type of interaction involved there. So actually this is how you are going to have the type of interactions. In this case, if I will talk about the mean lifetime of a strong interaction, that is negative 23 power of 10 seconds. The electromagnetic 10 to the power negative 21 seconds. The weak 10 to the power negative 11 seconds. That's what we are going to have. So least time is this for the mu, okay, then for the center one, then for the last one. So if we are going to consider the, okay, least is for this because negative power is greater here, this is least, this is in between, this is the highest value. So mu1 should be the highest one here, and here it's shown. Then your rho1 is the least one because the negative power is there, so this one, okay. So which means your option C is the correct answer. What we have done, we have firstly check out the type of interaction. The second thing we have done is talking about their lifetime, and then third thing, we have to just select what is the right option here. That's how you're going to think about the things, and you're going to get your final answer. Let me know if in case there was anybody having any doubt, and if everything is clear, that's great, great, great. I'll give you the next question, guys. Now I can see your comments, guys. Earlier they were not visible, and now we have talked about it. I can see Deepika's comment there, and Sakshi saying options, it's here. Okay, now that's great. Let me just give you the next question then. Let's check this one. This is A1, A minus A2, A to the power 2 by 3 minus A3 Z square, A to the power negative 1 by 3, A4, A to the A minus 2Z square, whole square basically, A inverse, where Z is the atomic number and A is the mass number. Of the nucleus if A4 over A3 is equal to 30, the atomic number Z for naturally stable isobars constant value of A is isobars is actually in terms of constant value of A whenever A is a fixed value. The options are like I have given you expression earlier which was having 0.015 written there, but this time the A4 and A3 value ratio they have given you. So what we can do, we can either write the standard or we already have the binding energy expression given. We can differentiate it with respect to Z and equate it with 0. That will give us the expression in terms of A4 and A3, or otherwise there is one more equation you can prepare and that's gonna help you to solve it quickly. 128 divided by 60 plus A to the power 2 by 3. That's what you have to consider. Now I'll write that expression in terms of A3 and A2. Sorry, A4 and A3 soon. If something is not clear and you want me to read it for you, you can tell me. I'll be just telling you what is mentioned there, guys. That's great, Sakshi. I'm gonna wait for your reply. Very good, Sakshi. That's great. Okay, now let me just even quickly tell you how you will write that Z value for the most stable isobar in terms of A4 and A3 terms. So that's going to be a divided by 2 plus a3 divided by 2a4, a to the power 2 by 3. So that a4 over a3 was 30. So a3 over a4 will be 1 over 30. So that will give you a divided by 2 plus 1 over 60, a to the power 2 by 3. You just have to simplify this part now, which will give you 60a divided by 120 plus a to the power 2 by 3. That's how you're just going to consider it. Let me know if in case there was anybody having any doubt, but if it is clear, we are going to go for the next one then. Very good, Deepika. That's great. Very good, Sakshi. Let's take the next question, guys. The last term is mu n. This is 19, F, 9, and 10. 10 and E, 19. 19 is the mass number, that is sum of proton and neutron. This one is the proton number, and this one on the side is the neutron number then. Try it now, guys. I'll wait for your reply and then I'm gonna start the discussion about it too in just some time. Mhm. Excuse me. I'm gonna just have a look at the option, like the comments, so that if anybody's gonna say something in the comment section, I'll get to know. Or whatever is the right answer according to you. Options here. Question here. Options here. Yes, Sakshi. Waiting for your reply. Whatever is the right answer, guys, you can mention it. We can talk about it whether it is actually correct or not. Very good evening, Sneha Sheesh. Very good, Sakshi. That's great, and that's correct too. Let's talk about it quickly. So, actually, in this case, they have given you the magnetic moments of a proton and the neutron are this and this, where mu(n) is the nucleon magnetic moment. The values of the magnetic moments of the mirror nuclei, this and this respectively, in the shell model are closest to what? Okay, so what you have to do, you have to write the configurations as per the shell model initially. So when you will see the number of protons in the first case are odd and number of neutrons are even. So we just write the configuration for odd number, which is 9. But in the second case, number of neutrons are odd, which is 9 itself. So again, we just have to write the configuration for that. When you will write the configuration as per the shell model for the 9, what you will have, let's observe that part here. So it's going to give you 1s 1 by 2 and you can have 2 nucleons in it, 1p3 by 2, and you are going to consider that simply how many you need, 9, right? So you are just gonna take 2 in this 2, 2 to 4 5 6 7 8 9. 5 6 7 8 9. We'll have 4 here, guys, right? And then we are gonna have the 2 in the next one. How many we had now? It's going to be 8 till now, and one more we need, which is 1d5 by 2 and the 1. So your j value of the last term in the configuration is what? 5 by 2, which is what? Which is going to be L plus half form, because 2 plus half will give us 5 by 2. So when your j value is similar to L plus half for the neutron and proton both, so your like magnetic moment corresponding to these ones will be what? For the neutron and the proton, you have to consider, right? Mirror nuclei, this and this, because you already had the odd number of proton in one case and odd number of neutron in the other one. So in this case, your first expression for the magnetic moment will be, which is mu n nuclear magneton, J plus 2.29. This is the formula. So in that case, what is J? J is equal to 5 by 2. Just plug it in here. 2.5 or 5 by 2, whatever you want to write. And then you are going to get 4.79 mu n. If you will consider for the second part, it's going to give you negative 1.91 mu n, because the one we had was for proton and the other one we had for neutron. So it's the direct expression for it. So it gives you negative 1.91 mu n for neutron and the first formula for the proton case. So your right answer is option D, which has given you the same thing, but you will say it's not exactly same. Out of the given options, if you will say which one is the closest one, so you will find it's option D, which is the closest one, right? And that's correct. Very good, Deepika. That's great. Very good, everyone. If in case still there is anybody having any doubt, just let me know. We will consider it. But if it is clear, that's great, great, great. We are going to take the next question. Also guys, as I have told you, today we will also have the spatial classes. So after this session, if anybody wants to join the spatial sessions, they can check it on my profile in the free live classes, the upcoming classes section, because they will start after this session today, like one by one. Let me just write the next question now. Let's talk about one more fact. So actually, here it is. Since the lowest two energy levels have angular momenta L is equal to 0 and L is equal to 1 respectively. Which of the following two nuclei have magic numbers of protons and neutrons? 12 says 6. Try it now and let me know what is the right answer according to you guys. And if you're not gonna get it, I will be considering that. Right, Sakshi? It's approximate one we have taken in the previous question. Try, try, try. Let me know what do you think is the right answer for this question. Options are here. Excuse me. Very good, Sakshi. That's great. So let me just discuss it with everyone too. So we are having the magic numbers, guys. The magic numbers are 2, 8, 20, 28, 50, and 82, and 126, right? In this case, if number of protons and neutrons both in any case will be equal to the magic number, that nucleus will be the most stable one. So if you will see the option A, here the number of protons are 2, which are equal to magic numbers. The other thing, this is mass number minus the number of protons gives you number of neutrons, which will also be 2. The other one is 8, which is also equal to the magic number. 16 minus 8 is 8, which is also equal to the magic number. Hence, in option A, we are having the protons and neutrons both equal to the magic number, and that means the option A is showing us the most stable nucleus. Very good, Deepika. That's great. Very good, Sakshi. Okay. So option A must be correct. But if you will check for any other case like option B, it's the first one giving you the number of protons 1, which is not a magic number. Second term giving you 4, which is not a magic number. The C option is showing you 2 for the first case, but for the second one it's 4, which is not a magic number. For the option D, again the second one is 6, which is not a magic number. Hence, the only option A is the correct answer here, and we are able to see like its number of protons and neutrons and how they are just exactly matching with the magic number, which makes it more stable. Okay, that's how you are gonna get it, guys. Now let's take one more question. It's here. Let ES denotes the contribution of the surface energy per nucleon in the liquid drop model the ratio, which is Es27 and 13 aluminium, Es64 zinc and 30 on the other hand, is options are 2:3. The next one is 4:3. The next one is 5:3. The next one is 3:2. Try it now and let me know what do you think is the correct answer. Otherwise, for this question, I'm quickly gonna start the discussion too. Very good, Sakshi. That's great. You got option B, right? Yeah. So what happens? Our surface energy in general, it's proportional to a to the power 2 by 3. Okay. But surface energy per nucleon, if it is ES, then in that case it will be proportional to a to the power 2 by 3 divided by a. So that will be negative 1, which will give you a to the power negative 1 by 3, right? So when you will take the ratio of this and this, so a is 27 for this and 64 for this. So 64 will be in the numerator and 27 will be in the denominator to the power 1 by 3, which is 4 ratio 3. And that's how your option B will be the correct option. But the most important point here is that you have to take the per nucleon, means you also have to divide by 1. Surface energy dependency on A, you also have to divide it by 1. So that's great. Very good, Deepika. Very good, everyone. So, guys, today we will keep it this much in this session. If in case there is anybody having any question, query, or doubt, you can ask it. Now, after the session, we are gonna have our spatial session, which is a free live class, which we will have on Unacademy Learning app. If you want, you can join it too. Okay. Let's keep it this much right now in this session. Here is the latest offer slide, guys, which is just valid till 12th August. And we are gonna have so many important and new courses starting on Unacademy in upcoming days. Even many courses are going on right now. So all these courses will be helping you a lot to take your preparation to the next level. And you can use and apply the code Anjali A Live whenever you will proceed further to take the subscription to get the discount in the total subscription amount. Because the offer is valid for a limited time. So in that case, even if any of your friends want to take the subscription, you can share this information with them too, as it will be helping them as well. Okay, so here are the benefits you will get if you will take plus iconic or the light subscription. All that has been shown here. Thank you so much, everyone, for joining this session and for attending it till the end. Thank you. Bye. Take care. I hope it was a helpful session. Okay, but if you will have any question or query even in the upcoming classes, you can ask about that. See you in the upcoming sessions now. Thank you, everyone. Bye. Thank you so much, Sakshi, for joining this session. Thank you so much, Deepika, Snehashish, and everyone for joining the session. Thank you. Bye. Take care.